parallel lines have the same slope. So if I have a line y equals k over L, x plus w, and I just picked some letters, y equals k over L, x plus anything here is going to be a parallel line as long as that thing that's put here is not w. So if I did a little bit of manipulating, what I would notice is that if I solved this for standard form, it would look like kx minus ly. Well, no matter what I do, if I manipulate this exact same thing, I would have kx minus ly equals negative, and then some thing here. Whatever's here would also go here. So basically what that means is that parallel lines retain their coefficients in standard form. So if the equation looks like this and it asks for a parallel line, notice that kx minus ly is going to stay the same. Perpendicular lines have opposite reciprocal slopes. So if I take something like this and I want a perpendicular line, I would have y equals negative L over k x plus some number, some y-intercept, or I could write it in point slope form or whatever. So what that means is perpendicular lines, if this gets manipulated over to here, if I manipulate this green equation, what's going to happen is I'm going to end up with Lx plus ky equals something here. So whatever's here would then get passed on to here. So perpendicular lines have their coefficients switch. So if it was in standard form, notice what happens to the coefficients. The k now goes by the y, the L now goes by the x, and one of the signs changes. So if there was a negative here, it becomes positive. If both were negative, one of them would become positive. If both were positive, one of them would become negative. The reason why one of the signs changes is that from this slope to this slope, one sign changed. If I change both the numerator and denominator signs, it doesn't change the sign of the fraction. So that means I only need to change one of the signs. So now let's do some problems really quick. Write the equation of the line parallel to 4y equals 3x minus 6 through the point negative 2, 5. If it doesn't tell us what form to do it in, then we can do it in whatever form we want. So I'm going to actually do this problem in two different ways. I'm going to solve this for y. So y equals 3/4 x minus 6 over 4, which is 3/2. So what I would do if I solved this for y is I can then take this slope and this point and plug it into point slope form, and I'm done. So y minus 5 equals 3/4 times x plus 2. So I can do this using the slope and a point. I can also use the method that I just learned with standard form. So what I can do is I can take this and rewrite it in standard form, negative 3x plus 4y equals negative 6, or do a little bit of manipulating to get the x positive. 3x minus 4y equals positive 6. And then all I have to do is take this point and plug it in for x and y, and then whatever the new number is, that's my answer. So 3 times negative 2 minus 4 times 5 equals some number. Well, that's negative 6 minus 20, so negative 26. So the answer is 3x minus 4y equals negative 26. And what you'll notice is that if I manipulated this point slope equation, I would end up with 3x minus 4y equals 26. So let's do that again. Write the equation of the line parallel to 4x minus 5y equals 13 through the point 2, negative 3. I'm just going to keep 4x and 5y, or minus 5y, the same. And then I'm going to sub in 2 here. So that would be 8. I'm going to sub in negative 3 here. Minus 5 times negative 3 ends up being 15. So this ends up being 23. So 4x minus 5y equals 23 is going to be the equation. Now, if I have these two problems down here, if they give me a slope I'm not going to go into standard form. It's easier to just do it like this. So y plus 8, I'm going to use the point here. Y plus 8 equals 3 times x plus 6. Here, I'm given a slope. I'm just going to use point slope form. Y minus 4 equals negative 3 x plus 1. I'm only going to use this standard form trick. It's not really a trick. It's true all the time. But I'm really only going to use this standard form thing if I have something that's easy to manipulate into standard form. Okay, perpendicular lines. Negative 3x plus 4y equals negative 6. Now, with a perpendicular situation, what I'm going to do is I'm going to flip the coefficients. So I have 4x and then plus 3y equals some number. Notice that I change one of the signs. So now what I'm going to do is plug in negative 2 here and 5 here. So I get negative 8 plus 15, and I get 7. That's my final answer. I also could do the exact same thing I did on the first side and solve this y equals 3/4 x minus 3/2, get an opposite reciprocal slope and do point slope form. So I could do y minus 5 equals negative 4/3 x plus 2. I could have done that. This one is in standard form, so I'm going to simply flip the coefficients and change one of the signs. Now I sub in 2 here and I get 10. I sub in negative 3 here and I get negative 12. 10 minus 12 is negative 2. And I'm done. Instead of having to solve for y, find a slope, do an opposite reciprocal, this is turned into a one-step problem. This problem, I'm going to take the slope. Y plus 8 equals opposite reciprocal, so negative 1/3 x plus 6. Opposite reciprocal, this one's going to be positive 1/3. So y minus 4 equals positive 1/3 x plus 1. One last question. What happens if I have a situation where I'm given something like this? I'm given a line, 4x plus 2y equals 13, and I want it to be perpendicular through 1, negative 3. Well, when I flip these, I have 2x and minus 4y. So I would, if they're both positive, I just change one sign. If one of them's negative, I would change one sign. I don't know why I wrote 10. That's kind of weird. Do I have to simplify it? That depends on the teacher.